Good afternoon. So my name is Jianping or JP Jiang. So I'm the VP of CXL product marketing and business operation at Xconn Technology. We're a 3-year-old IC startup in Silicon Valley. So glad to meet you. So let's start to talk about our product. So yeah, many years ago, I was working at Broadcom, and my marketing VP always say, "Hey, whenever you sell some product or feature, right? If you can explain that to your mom or some non-tech housewife, then you will be getting there." So he always starts saying, "I told my mom." Right? So I was a little bit amused, but later I think I figured out. I think the better you understand that technology, what's the use case, you can explain that to people, let's say every Joe, what that's about. So let me try it. So what is a CXL switch, right? So this is a map of Italy. So many years ago, I also stepped into that country, and a couple hours later, I just told my wife, say, I love this country. I want to come back more visit. But as I'm fascinated by Italy, I look at the Roman Empire, and there's a saying say all roads lead to Rome. So I know the the meaning of this word, but I also think this word also means Rome is actually kind of a switch or everything coming together. So we are basically the CXL word. CXL is building the connectivity for this modern computing, right? All these data center and AI computing need a very fast, very efficient connectivity. And our CXL is more like a Rome for this Roman Empire. So if you get that really built up really well, very efficient, it'll support your computing system more effectively, more scalable. So the picture shows, this is a picture that's like people try to come up with, what that looks like in many years ago. So actually, I also asked ChatGPT, right? How many roads lead to Rome? So guess what? The ChatGPT doesn't have an answer. So, but it pointed me some number like that at the peak of the Roman Empire, the total road is like more than 250,000 miles. So I imagine, not only those roads, there are some also ships going to Rome, right? Because this is basically a kind of a scalable infrastructure to support this empire to get everything done efficiently and to expand. So question, how many roads to Rome and what kind of road? So let me go to the next one. This probably answered as far as we want to build a CXL switch, which is a Rome for the Roman Empire, we have the answer. We basically have 256 big roads. Each road is running at a speed of PCIe Gen 5 speed. So that's very kind of high level tells you what kind of the switch we're building. And this is the switch, which is the first CXL 2.0 and also PCIe Gen 5 switch. And a tremendous amount of length. So never saw this kind of switch before. And also the switch is very efficient because the port-to-port latency is very short. So people talk about CXL, all this memory pooling, memory expansion. And the critical thing about this memory usage is latency. And our switch basically optimizes all this latency to a very minimal latency level to support this kind of usage case. And our switch is initially just targeting for this CXL and data center usage. So we optimize all the power consumption modeling to make sure the power consumption is going to minimal as well, because power consumption is also critical in the data center world. So our switch is already silicon. So people sometimes think, oh, is that your FPGA? No, we already have a silicon last year. So it's been in our lab almost more than half a year now. So our switch will actually work with today's CXL 1.1 servers, whether that's from Intel or AMD. And also many CXL memory devices, including the devices from the big DRAM vendors. And this CXL 1.1 actually doesn't have this concept of switch. However, we have some proprietary way of having these CXL 1.1 processors to work with our switch and to enable the memory pooling, memory sharing, and of course, memory expansion for sure. So, and then it's going to be future compatible with the CXL 2.0 processors. So the 2.0 processors is the next step. The Intel and AMD, they're going to come up with in their roadmap, the processor. And we're going to be compatible because our IP is already CXL 2.0. Also remember, this is a chip also can be a PCIe Gen 5 switch. So the nice thing about this is PCIe and the CXL, they're going to coexist for some period of time, because PCIe is a very kind of legacy. A lot of devices, they're seeing the CXL, but they are going to take time to transition to that. The hardware transition going to take some time. So our switch can actually work in a hybrid mode. It means we can support both PCIe device and the CXL device at the same time. So that's a nice thing to bridge the transition, because the computing world, take many years to evolve. And our engineering sample ICs are already available. So we are already working with some early customer on their prototype systems. So I'll stop here if any questions you want to ask. All right.
So are you saying right now you have your own proprietary methods in order to allow it to use the switch, but in the future that won't be needed, you're saying, or?
Yeah, because in the CXL 1.1, there's no switch.
Right.
And the customer, they still want to get memory pooling enabled, because that's memory pooling is a tremendous value for the hyperscaler, for the HPC customers. And we have ways to do that.
But in the future, that won't be necessary in the future versions, you're saying?
Yes,
right? Okay.
Once the processor go to 2.0, everybody on the 2.0, everybody just speaks the language of 2.0, and we're good to do everything in 2.0.
Yes. Just following up on this, so you said right now with 1.1 you do memory pooling, but you do it proprietarily outside of the specifications, because the specifications do not include memory pooling with 1.1?
That's correct.
Okay.
Yes. So this page kind of showed our, on the top you can see it's our silicon. And also on the bottom I showed the left side of this box is a very early version of what Xconn made for their prototype switchboard. So in the middle is our chip, but it has a huge fan, because initially we got the first silicon. We're very conservative on the power side. We put a very huge heatsink on top of it. And on this board you can see there's so many ports. There's two of the CAM slot, PCIe slot, and the rest are MCIO connectors. So all these connector and CAM slot basically covered all the 256 lanes. And the right picture is our latest kind of we revised the design of this switchboard. That's kind of a 3D image of our board that's coming up. But you can easily see the heatsink got much reduced, smaller, because our chip, we understand how much power it consumes. So.
How much power does it consume?
Right now, okay. Yeah, so our chip is at, all the port kind of at peak throughput is somewhere around 120 watt to 130 watt.
How do you compare that to a PCIe switch, so people have a better understanding?
I think a PCIe switch, that's relatively, we are compatible. We believe our port consumption is lower because when the switch vendor, they provide their data, you have to look at what kind of data, their power consumption they set. So, and then we said, the peak, basically you're running all the port at the highest throughput. But normally when in the regular operation, that power going to be much lower.
So you said it's a reference design. Are you going to be licensing your technology for others to build it, or are you going to build the actual hardware?
So we are doing this reference design because that's kind of the tool for internal validation.
Okay.
But some customer also take this one for their prototype. But of course, we have all the schematic and the design. If some OEM or ODM, they want to design their chassis, they will take our design to start with.
Okay. Yeah, I could imagine the hyperscalers will build their own.
Yes.
So do you believe your switch is ready for software developers to develop code?
Yes, we're at that point to enable the software development. We are very closely with Charles' team on Memverge, and also we have a partner as well. They're working on the fabric manager management software side.
Very good.
All right, so let me show you. This is a picture that one of our OEM or ODM, they want to design this kind of a chassis, right? So on the left, that's a chassis designed around our switch. So there's a BMC, there's also MCPU to manage the switch. And the switch will come out with an output port, which through the CDFP cable, it can connect to another box on the right. And that box is on the right is a kind of what we call a J-bomb, just a bunch of memory, right? So these are kind of connect to each other. And of course, there's some port going to connect to some server, let's say Intel Sapphire Rapid or Genoa. So this kind of system allowed a complete, server switch to memory, kind of very basic to enable this memory expansion and memory pooling system to work. So we're going to have this kind of system, and this going to also a developed vehicle to allow a lot of software development and so on.
So how much RAM can be added then to that module?
Sorry, about the module?
How much memory can be added to the J-bomb?
Well, the memory module today, we see a lot of, the by 8 memory module, CXL memory module. So our switch actually is total 256 lane, and our production chip are going to support by 8 bifurcation, so total 32 ports. So if you just, let's say you reserve the 2 ports just for the server side, the rest 30 you can basically connect to all the memory module you want.
So would that equate to 7 terabytes of RAM using the...
It could be up to 16 terabytes of RAM if the modules are 512 gigabyte.
Right.
And you probably have seen announcements by major memory suppliers that they're targeting 256 gigabyte and 512 gigabyte CXL memory modules.
Okay.
So 16 terabyte of memory in one chassis is tremendous.
If you use Chrome.
Right. Thanks, CMAC. So actually, I'm going to talk about some of the usage case. So scalable memory expansion. So I put a scalable because the switch is something make the system scalable. We talk about the Roman Empire, wherever every road lead to Rome, right? In the CXL system, I would say for this transportation connectivity side, every road lead to a switch. Of course, the server, they are going to be the processing all this data to provide this processing power and accelerator, GPU, all these things. But in terms of data connectivity or the transferring, they're going to be much scalable through a switch, because that allow you to expand further the system, not locally, just a couple servers and a couple modules, but wherever the scale you want to do, you can go through.
Of course, if one goes to so much memory capacity, bandwidth needs to go along with it. So it is possible, it's likely that more than one link to the host you need,
Right.
or 15 terabytes of memory. So it is safe to say that each host might want to use at least 4 ports for the host connection. So maybe instead of 15 terabytes,
Mm-hmm.
maybe you get 10, 12 terabytes of memory for a JBOD. That
Sure.
is just a matter of bandwidth and capacity match.
Right.
But perhaps the point you're making is customers will have a choice. If capacity is more important, they can just use less bandwidth.
Yeah. So for this one, I assume they concentrating on the capacity, not the bandwidth, right? So yeah, as you said, if they also need bandwidth, they might want to, the host might want to take a couple of the lanes to the switch, and then that leaves less lane for the memory modules. But there's a lot of applications that in-memory database that consumes a lot of memory. They can easily expand through this kind of configuration to allow 15 terabyte, or if you have 4 of the CXL connection to the switch, you can easily expand the 4x. Right. So let me move on, because expansion is one thing, but hyperscaler, they are super interested in the memory pooling. And I just borrowed this picture. It's very, people in the CXL, they see this picture a lot, but I kind of changed the pool to become more like a pool. Pool means you throw any kind of devices into that pool, it just works. Because our switch also support a hot plug-in. So you can plug in a module, you can plug it out wherever you need it. So in the first generation, when the memory module or the memory device are single logical device, we can, and even the host, 1.1 host, we can still enable this memory pooling. But later, when the host becomes CXL 2.0 and the memory module become MLD, multi-logical devices, our switch also supported it nicely. And also the switch can also cascade. It means later you can see something called a FAM, fabric attached memory. That's basically defined in the CXL 3.0, but that 3.0 going to get covered by our next generation product. So yeah, that's for the memory pooling. Again, you can have a very big pool, and also the memory can be shared among multiple hosts. And these okay, go ahead.
Sorry. So have you been working with, maybe you're obviously working with engineering samples with hyperscalers, the fabric manager, obviously there's going to have to be a layer on top of that for the orchestration regarding dynamic allocation of memory across hosts. Have you been working on any solutions around that?
Yeah, I think the fabric manager is a critical part for this whole picture to work, because the fabric manager kind of the intelligence to allocate this resource and put that into the usage.
Craig, if I may comment on that as well, as CXL teams talk about CXL Fabric Manager, we think of the CXL fabric management function to
Mhm.
be a low-level function.
Mhm.
The orchestration you mentioned is a high-level software function that can be running on the host for managing more than just one server. The orchestrator is perhaps worried about many systems and the composing and such. That is not defined by CXL specification. What is defined is the CXL Fabric Manager APIs that allow binding of memory or accelerator resources to the CPU. So that's a kind of a low level, firmware level function. On top
Mhm.
of it, here comes the OS or hypervisor. And on top of that comes this orchestration layer that you mentioned. All of these need to be working together.
Yeah, so the likes of say VMware would extend DRS functionality to factor in allocating RAM to appropriate hosts using the standardized Fabric Manager level API. So, and other vendors might do it, other hyperscalers might do it differently, but they're all using the consortium standardized Fabric Manager.
Correct.
Okay, yeah, thanks, CMAC, answering on the good question about Fabric Manager.
Maybe the main point of this discussion was the CXL specification provides the APIs, the hooks, the methodologies. There is still a good amount of opportunities for other suppliers and developers to build differentiation on top of that. Robustness, agility, scale, all of that can still come at multiple layers.
And of course, we switch enable a very big memory expansion and a big memory pooling. So how to really utilize all these resources. And the more cascading, yeah, you probably introduce some different tiering, right? The latency performance tiering. And the people, they're not only want to do the CXL DDR, they want to expand it to other kind of memory storage media. All these tiering and things that need to be handled by software. So